So welcome to another segment of my chemistry video. So in our discussion, I'm going to talk about the empirical formula under your stoichiometry calculations, your more concept. So stoichiometry is just a word for chemical calculations. So we are looking at the empirical formula. So you need to understand what the empirical formula is. But what exactly is the empirical formula? Well, when we talk about the empirical formula, it is simply a formula that shows the simplest ratios of atoms in a compound. That is what we call as being the empirical formula. We can simply say empirical formula is a formula that shows the simplest. So that shows the simplest ratios of maybe I can say different atoms in a compound. So that is what we call as being the empirical formula. A very good example is that formulas such as glucose from your biology, C6H12, then O6. Is this the simplest ratios of atoms? No. If you look at that one, there are 6 carbon, there are 12 atoms of oxygen and 6 atoms of oxygen. You can reduce that by looking at the highest number. 6 there is a 1, 6 there is a 2, and 6 there is a 1. So meaning the simplest ratio for that one is going to be CH2O. So that is the simplest ratio, and this is what we call as being the empirical formula. Let's take, for example, you have got ethene, C2H4. Again, when you look at this one, there are 2 atoms of carbon and there are 4 atoms. You can reduce that, 2 there 1, 2 there 2, so it can be CH2. So this is what we call as being the empirical formula. What about if you consider the formula, H2O, water? If you look at H2O, how many atoms of hydrogen? There are 2. How many atoms of oxygen? There are 1. So can you reduce that one? No, you cannot reduce it. So sometimes the molecular formula is the same as the empirical formula. What about when we talk about sulfuric acid? Well, for sulfuric acid, it has the formula S2SO4. What is the empirical formula? Well, you might be tempted to say HSO2, but that is actually wrong. Let's go back again and rewind it. If you look at sulfuric acid there, how many atoms of hydrogen are there? 2. How many atoms of sulfur alone? 1. How many atoms of oxygen? What is the highest number that can go there? You can't reduce that further. So therefore, the empirical formula will still be maintained as that. So that is what you need to remember. So the empirical formula will show the simplest ratios of, or the lowest ratios of atoms in the compound. That is what we call as being the empirical formula. Now it is possible, when you have been given the percentage composition of all the elements by mass, you can get to know the empirical formula. So let me just guide you with the steps that you can do to find the empirical formula. So now what you're going to do when you have been given the percentage, remember they are going to give you the percentage composition. So they'll give you the percentage composition by mass. So if you have been given the percentage composition by mass, you simply divide by the relative atomic mass. Yeah. Why are you dividing by the relative atomic mass? To find the more ratio. That is what you need to do. So this one, finding the more ratio. So that's the way we do it. So once you do that, the next step that you need to do is simply divide by the lowest. So you divide by the lowest number, to find the simplest whole number ratio. So that's the idea that you are going to do. Then lastly, after you do that, you can write now your empirical. You can simply write the empirical. You can now write the empirical formula. So basically That's what we do. So a quick step, they'll give you the percentage composition by mass. You just divide that by the atomic mass to help you find the mole ratio. Then you divide by the lowest number, to find the simplest whole number. That's what I mean. Basically, that is what you are going to be doing with that. So let me give you a very good example. Let's try to look at an example. Let's try to show you an example of what I'm talking about there. So I can tell you to say, find the empirical. So find the empirical formula. Find the empirical formula of a compound with percentage composition. So with percentage composition, 80% copper and 20% 20% sulfur. So imagine that you have actually been given such a one, and they want you to work out. It's not complicated. What you do, follow them the way they have given you. So they have given you copper, Cu, and sulfur. The percentage of copper is 80 and that of sulfur is 20. So the first step, this percentage composition are supposed to be divided by the atomic mass of copper, which is 64, and sulfur, which is 32. So what will that give us? So when you divide there, that will be 80 divided by 64. So 80 divided by 64 give me 1.25. And what is 20 divided by 32? That is going to give me a 0.625. Do you remember the next step after you divide by that? You divide by the lowest number. So what is the lowest number that you have between what you have? Of course, it is 0.625. So you divide throughout by 0.625. So when I divide by 0.625, I know this will give me a 1. So we can just say 1.25 divided by 0.625. What is that going to give me? It is giving me a 2 there. So what you have gotten there is simply what we are calling as being the mole ratio of atoms. So meaning that there are 2 atoms of copper and there's 1 atom of sulfur. So therefore the EF, the empirical formula now, will be equal to, so you write these as subscripts. So the 2 will go at the bottom, and as remember, we don't write 1, so you just ignore it. So that is, in this case, the empirical formula. So it was copper, copper sulfate. Copper, in other words, copper 1 sulfate. That is what you had there. Let me show you another one that you can actually work around with. I'm going to use maybe an example of the formula that we did look at. I'll give you the percentage compositions of what we did look at. So if you remember the percentage composition, I can tell you, that's number 2, find the empirical. So find the empirical formula. Find the empirical formula, of a compound. So we can say of a compound with composition. So that is the percentage composition. In this case, I can tell you sodium. It has a percentage of 43.3%. Then, sulfur. Let me say, carbon, which has a percentage of 11.3%, and oxygen, which has a percentage of 45.3%. So they want us to find for this one. So very simple, follow them the way they have actually arranged them. So in this case, I've got sodium, I've got carbon, and I've got oxygen. So what's the percentage? It is simply 43.3 carbon, 11.3, and oxygen 45.3. What did we say? You divide by the the relative atomic mass. This is 23, this is 12, and that is a 16. So what are we going to do? It will be 43.3 divided by 23. That is going to give me, okay, I can leave it to maybe 3 significant figures. It will give me 1.3 8, 8. That is what it is giving me. Then there it is 11.3 divided by 12. That is again going to give me 0.9242. Let me say 42. And the last one there, 45.3 divided by 16. That is going to give me a 2.83. Right? Then what we can do is that we can divide by the lowest. Of course, the lowest is this one, 0.942. So I'll divide it throughout by the lowest, 0.942. Of course, here to give me a 1, let's try to see if 2.83 divided by 0.942. What is that giving you? Of course, if you look at it, you can just round it off. That will give you a 3. And if you look at 1.88 divided by 0.942, that one again, you can actually round it off. That is going to give you a 2. So that is, this is what we are calling as being the mole ratio. So that simply tells you there are 2 atoms of sodium, 1 atom of carbon, and 3 atoms of oxygen. So therefore, the EF, the empirical formula, is going to be Na. Remember these ratios, you write them as subscript. So it will be a 2, a CO, and that will be a 3. So that is sodium carbonate. That's the formula that you have. Well, thank you so much for watching. Watch out for more videos where I'm going to teach you about how to find now the molecular formula.